welcome everyone. We've got a really full, great panel here. Starting on my left side is Kevin from Nervos, Benjamin from Elrond, Jack from Skale. And Jack's laughing at me because I told him in case I mistaken him for the other founder, I got a hall pass. And of course, Anatoly from Solana. So I think one of the things is scalability has been a topic almost since the dawn of time of blockchain. And I was looking at something back 3 years ago, and I'm like, 3 years, where are we? How are we going to move forward? So today, the whole purpose is let's hear from these guys, from layer 0 to layer 1 to layer 2, how are we going to tackle this problem? And more importantly, what is the progress at this moment in time? So my challenge is, before I let you guys introduce your project, right? My challenge is you cannot start with, I'm a high throughput next generation blockchain. But I want to hear more about your killer feature of the project. What special angle are you working on? And how is that tackling the different components of scalability, from throughput to latency to data storage efficiency to cost efficiency? So Kevin, take it away. I think it's already on.
Hello? 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 Can you hear me?
Yeah.
Okay, so we're not a high throughput solution. We're actually, TPS or throughput in general is not our goal. It's not a goal of Nervos. And so Bonnie just mentioned quite several properties that, in our view, it's not possible to have them all in one blockchain, right? So, there's also more like privacy and things like that. It's just not possible to squeeze everything within one blockchain. So what we're doing is we're going to take the properties that are sort of further from application-specific concerns, which is decentralization and security, and have those. These are more infrastructure concerns. So as for Nervos, we have a base layer protocol called Nervos CKB, Common Knowledge Base, and that is focused on these two properties, which is security and decentralization, which means we're not going to compromise these two at all. Because when you start considering putting more things in the single protocol, then engineering is all about trade-offs. So you are going to have to make trade-offs and conflicts. And that's something we don't want to get into. Whereas all the other properties, including scalability, privacy, finality, other concerns, transaction throughput and cost and so on, these tend to be more application specific, which means different applications will prioritize different properties. And then we just, I don't know what's the best word, but we have layer 2 technologies or layer 2 tech to take care of those, right? So we just focus on being a really, really good layer 1 protocol.
Ben?
Sure. Working? Yes, sure. So I think the really interesting point we've seen these days is that after you have a blockchain architecture that has been in the works for 10 years, and then another really significant one like Ethereum, which has worked for a few years, you can learn a lot of stuff about what matters and what doesn't matter so much. So at Elrond, we've thought about how to build a base blockchain architecture that is especially focused on creating a network that is adaptive and has some sort of linear scalability, meaning that as the network grows, you basically, with each shard, have much more throughput. The whole idea was that you want this core functionality in order to have applications built on your layer. But then we also noticed that the second most important thing after you build a high throughput architecture, as marketable as that sounds, is that you need efficiency, meaning that the next important milestone for any kind of architecture which wants to scale is how do you do it within a world where you have resources that cost a lot. So we made sure to bring a new consensus algorithm based on proof of stake and PBFT, where you not only eliminate the energy and computational waste problem that comes with proof of work architecture, architectures, but also through a BBFT consensus mechanism, we make sure that latency is really minimal. And you can use this for real-world applications, not only keep it as an abstract ideal you tend to attempt to achieve.
And Jack, I know we talked a little bit in the room before this. Help us demystify, because when I go online and read about Scale, people link you with Plasma. So are you another iteration of Plasma?
Yeah, great. Hello, hello. You working? You hear me? Okay. Great question. So I'm going to first just take a step back and just because we were also having a discussion about scalability and, hey, is this going to be the same conversation that was had 3 years ago at this conference? Is it going to be the same track? And I think it's going to be, we're at an entirely different conversation. I think we're going to see entirely different results over the next 6 months. Scalability is a problem that's being attacked globally. I don't know if I've ever seen a problem targeted at such scale across the globe. So, and one thing I think, to be successful in solving this problem, you have to have a good vision on where the industry is going, how scalability will be solved, and really, what do developers want? What do engineers want? What is safe, secure, easy, and fast? So our belief at Scale is that we're going to have, and probably echoing some of Kevin's comments, but we're going to have firm, slow, really resilient layer 1 chains that are proof of work oriented, that we know are secure. And then augmenting those first layers will be, in our opinion, layer 2 chains that run fast, and hundreds and thousands of these layer 2 chains that can all message with each other and message back to the main chain. So to your question about is Scale Plasma, is Scale not Plasma, I'd say, one, I think the definition of Plasma has been loosely defined. And I would say that my understanding and understanding from a lot of people is that it was initially meant to be a very open design spec. It is now really become a certain design spec that has followed this lineage of the original white paper from Vitalik and Joseph Poon. And in that category, Scale is not at all a Plasma. We are a side chain. We are an open layer 2 scalability network. And we very specifically are focused on running smart contracts in layer 2. So we don't call ourselves a Plasma. Some people do, and I wouldn't go as far to, like, even some of our investors, but I wouldn't necessarily say they're wrong, because I think we need a definition to mitigate any confusion. We're calling ourselves a layer 2 scalability network and a sidechain.
Got it. And Anatoly, last but not least, we've known you guys for a long time.
This is on.
This is on, finally. Test one.
So what's different about us is that we're not sharding. We're just a really, really fast, high-performance blockchain that never splits its state. So we don't have to compromise on security or privacy or any other things, as far as I'm concerned. So what was the second part of the question?
The second part I will ask you now is that we've known you for a long time. I remember when we first read about the new idea of proof of history. In our heads as investors, we're like, hey, proof of history, proof of love, proof of devotion, how many more proofs can there be? But when we read through the mechanisms you put in terms of allowing for parallel scaling, love to hear more about that angle of your project.
So what's unique about us, it's about last year I started really thinking about this problem, and I was trying to find other physical barriers like proof of work that actually are bound in physics. And what I stumbled on was time. And for a moment I thought I invented verifiable delay functions, but there was a big pile of research that was done for a long time before me. And what I really did was just really add a VDF inside the ledger data structure. So imagine like your general blockchain, whether it's append-only chain. If instead of like work being as the thing that you're appending, you're actually proving that time is passing between every block. So this chain grows in real time. And the interesting part about it is when it forks in partitions, all the partitions grow also in real time. And that gives you a synchronized clock before consensus. And once you have a clock in a distributed system, there's a ton of optimizations you can do to simplify all the messaging and reduce overhead to coming to consensus. So that's basically it. Beyond that, while that solves one problem, the actual hard problem of getting software to do what the hardware allows is kind of what I call blood and sweat of engineering. for $5,000, you can build a machine with 14,000 CUDA cores. So that should do about 1 million at 255 signature verifications per second. That means your single node could actually process that many transactions per second, right? So that's what we're building. We're building software that can take advantage of every piece of silicon in there. So when you're talking about linear scaling, in my mind, I'm working on exponential scaling, because 2 years from now, we're going to have double the cores. So my goal is, to soak up 400 gigabits worth of transactions, which would be around 300 million per second.
I see a lot of head noddings. Any responses to that?
Please challenge me. Call out bullshit.
He's calling you bullshit.
No, I would just say you're preaching to the choir here. We're doing the same thing from a layer 2 perspective and have a parallel infrastructure to, I think the mindset is, if you look at DAP Radar today, what sort of scalability do we have? If you solve for that problem, you will be behind in 2 years. So I'm agreeing that this mindset is the right one, and we have a similar approach.
I'm sort of still curious if you stumbled into any serious obstacles there, because it generally tends to sound a bit better than it really is when you build it.
So right now we're disk bound. So when you're building stuff, you typically use cloud providers, and they really throttle all the I/O ops. Not so much bandwidth, but number of per second operations you can do on hardware. So it's about like 3 times worse than what you'd expect out of hardware that you build yourself. But building out a network with a bunch of nodes is a big pile of work in itself. So using Google Cloud is what we're doing right now. And there we can do about 125,000 transactions per second steady state without blowing up. This is verified up to 150 nodes. There's some networking bugs there which will blow up when you scale the number. But in theory, our finality should grow with the log of the network. So right now, our problems are blood, sweat, and tears. It's hardware. Like, virtualization sucks, hardware sucks.
But I'm especially curious on communication, and then we can come back on that. Do you have any kind of limitation with respect to bandwidth? What kind of bandwidth do you presuppose in order to be able to propagate?
You basically, our data structure, like this ledger, what's really cool about this is once you have a source of time, right, you as a node, you can receive this data structure any way you want. I can ship you a hard drive, and you can objectively derive the time and order of events as presented by this partition without witnessing them directly. So given that, you can compute the active set of participants at that moment in time as presented by this ledger without actually talking to them directly. So this data structure can be downloaded like bandwidth. So we can do this bandwidth fan-out optimization, so bandwidth splitting. So in terms of messaging overhead for the data plane, it's as efficient as you can be. So if you have 1 gigabit network, in theory, you could use half of it effectively to fill up with transactions.
Okay.
And I see Kevin here in deep thinking. Any comments on?
Yeah, I definitely, we were on the panel with the Solana team before. I think I'm very, very intrigued with what they're building. One thing we're interested about is, what do you think is the order? I feel like we're all just just asking them questions. What would be the order that you see the bottleneck would be? Like, is it going to be first computation, then bandwidth, or is that, your computation is very, very parallelable, so you're probably not going to hit that anytime soon, right?
Like, networks take such a long time to roll out. Like,
Yeah.
we're going to be bandwidth bound forever.
Yeah.
Like,
Yeah,
until we have like neutrino detectors or something
right.
like that.
I think that's what I suspect too, and for us as well. So when you think about bandwidth, like for us, for example, we want to optimize for like a residential bandwidth, not data center bandwidth, for example. So the idea is for Nervos, for example, we want to try to push on more set on the decentralization, which means that we're probably not going to talk about gigabyte, and by the way, we also use POW, which means everybody can join and can become a miner. And if I'm just mining from my apartment, that will be fine too, right? I can be a full node and stuff like that. So we want to be on the protocol level. We still want to support that and probably have, not different from what Bitcoin does. And we're probably not going to set the block size exactly where they are, but we're also going to set one so that it's possible to run node from like a residential settings. I think it just, again, like I talked before, it's all trade-offs. So like, where do you want to sit in the trade-offs?
And I think one of the things Kevin did not mention is he's being very humble about the background of his team. I know your team has been working on the open source space, contributing and also working on the very early generation for Ethereum for a long time. So tell us a little bit more about Nervos, because when I looked at Nervos, this whole architecture is a very ambitious architecture with multiple layers. How are you guys going to manage delivering all of that? And also, what are your thoughts in kind of, phase one? What are we going to see?
So it definitely helps that this is not our first blockchain project, and then in the past, like what Bonnie said, we help our chief architect Jen. He worked with the Ethereum core team, and then our engineering company basically built a permission blockchain, which is EVM compatible and very high throughput. So on the layer 2 side, and this is, by the way, how we got the inspiration of building, Nervos and as a layer architecture, because what we see is when you push the TPS throughput to, tens of thousands level, we actually didn't use the GPUs. I think, with the GPUs, I can definitely see that would be a huge leap in terms of TPS. But anyway, but there are problems, right? So with when you increase throughput. And this is where we want to step back and say, hey, maybe these are just layer 2 concerns. So in terms of deliverables, I think we already have a layer 2 solution that we built and delivered. And right now we're working on layer 1, which will launch towards the end of this year and December, January time. And we're open source this month. Yeah.
Calling all
Congratulations,
developers.
that's awesome.
Yeah, we are. Yeah.
And then slightly change of topic, right? I know, Ben, you mentioned you guys are working on sharding. Now, sharding is something that we're all familiar by now whenever we talked about scalability. And we've known there's been quite a few teams working on either transaction or both transaction and state sharding. Maybe if you can help us understand a little bit more, what is the angle of sharding you're working on? And also, as we all know, it is not a new concept for just blockchain. Companies have deployed it in traditional databases. Google, Facebook all have their own sharding algorithms. But one common vulnerability for sharding is how to ensure that any single shard is not under attack easily, and ensuring that layer of cross-shard communications. Maybe you can help us understand a bit more.
Sure. So I think just binding this to the discussion we had, there's always a really important discussion about how you want to do the computational part. And then there's the kind of limitation that most projects do not tend to discuss about, and this is the bandwidth and communication problem. If you presuppose a kind of 10 gigabit or 100 gigabit bandwidth, then you could say you would have unlimited scalability, but that would not help you in the real world, because in the real world you have some really serious constraints at this point. What we are focusing on with respect to sharding is a kind of adaptive model of sharding. What sharding does, it basically allows you to partition the network into smaller networks so that you can process transaction in parallel. And our particular model focuses on having an adaptive model rather than a static model, because we presuppose that a network should be like an organism. You first have some nodes that join the network, support you, but then as the network works really well, a lot more people join. And this is the really interesting part, that as the network join with a state sharding model, you have practically a linear scalability and increasing throughput with each shard. There are, however, some interesting security challenges. And one of the main things we've been focusing on is bringing a kind of secure proof of stake consensus algorithm in combination to this sharding model in order to increase the security. So with respect to consensus, we have consensus running in each shard. And the consensus is really interestingly done through random sampling of the group for each block committed. And so we try to make it really unpredictable, who will be in the consensus group, and then once you discover it, you have a very limited amount of time, even for a highly adaptive adversary, in order to be able to penetrate the shard. There's still, I'd say, lots of challenges, so this goes gradual, and you always tend to discover some things you missed when you're building stuff. But yeah, we are advancing pretty good and hope to have something, the first version of the testnet in about 1.5 months.
Is the final state of the shard somehow committed back into like a main?
Yeah,
tree?
a kind of meta chain for us.
How do you secure that commit? Do the other shards process all the transactions, or are they simply commits the final result?
There's a few super nodes that
I see.
are selected from the pool, and again, randomly selected, so that you cannot know but have satisfied the criteria.
But do these supernodes process all the transactions?
Yes, they process the part of data that goes into the meta chain.
But so is that data, is that all the transactions that occurred in the shard, or is it some final state?
Some final state.
Okay. How do you know that the shard didn't lie about it?
So there's always the consensus that happens in the shard, and then if someone lies within the shard, then you have this slashing mechanism and also rating, penalizing, and then as soon as this is committed, then you basically, as long as it does not violate anything, there's a process that happens for the supernode as well in order to have the same, maintain the same data.
But if the whole shard lies, how do you know?
There's still a problem with respect to the whole shard, because you have some incentives there. If the whole shards, the kind of assumption is that 1/3 you have not malicious actors that are much higher, a higher number than 1/3 of the shards one third of the nodes in the shards. If you have more than 1/3 malicious actors, then the assumption breaks down.
So, I mean, that does seem like you're still lowering the security barrier, because I have like some security parameter for the entire network. If I shard it and then each one can be taken over by a third of that shard, then me as somebody that wants to short your token, I take a huge short position, attack the shard, and then that change gets propagated up.
Yeah, but this is basically really calculated. So you cannot predict who will be in the consensus group. Even when you join the network, you cannot foretell which shard you will be assigned to. There's a random distribution sequence, and you are assigned to a shard. When you are assigned to the shard, there's this kind of process where the whole consensus happens randomly, and you cannot know before who will be selected. And as soon as it's done, there's another consensus group. And there's another interesting feature we have. At the end of each epoch, 1/3 of the nodes are reshuffled into different shards, especially to decrease any kind of potential attack vector.
Okay.
And I think that's a great segue, because this is something that we know. If it was that easy, we've all been at full scalability. But oftentimes, I think the one thing we struggle at is how do you balance that against security, loss of security, and also decentralization. So the next segment of the talk, I want to know more about and share with everyone kind of your progress, right? And more so about, we all know every project is struggling of balancing these three factors. What is keeping you up at night? And what kind of challenges are you facing? Because remember, you got a full rooms of potential developers out here too who can help you solve the problem. So we've talked a little bit about sharding. Maybe we can start with Scale Labs this time.
Yeah, great. So when we think of, I'll start with the trilemma question and kind of go to challenges. So we think layer one provides another, I think, real strong support source in terms of getting decentralization and security for our model. And then as a layer two scalability solution for Ethereum initially, and we're talking to some other groups and like Nervos and excited about some other platforms. But when you combine a fully decentralized layer 2 network that has, again, a random entropy to put validators into subchains that then run consensus for decentralized applications, you, one, have a pool of, let's say there's 5,000 Scale nodes, so we still are able to maintain decentralization and security by having a BFT system and a work token, and we use a very strong asynchronous consensus that has fast finality, and we also use BLS signatures for messaging back and forth between chains and subchains back to main chain. So there's a security model there that by itself, frankly, I think would be a little weak, but when combined with Ethereum or a Nervos or a very strong proof of work chain, we really feel it's the perfect combination. And also, I think what we're trying to enable here is also accessibility. Every dApp out there should not need to hire a cryptographer to work on their team, okay? They need to be able to come and set up applications, and imagine all the different verticals. I speak to developers that are in genetics and healthcare and life science and insurance and retail, in gaming, et cetera. These people need to be able to take their core expertise and leverage scalability without having these assets on their team. So when we think of, I'll fold into challenges now, back to your question. So for us, we don't know who the top 10 dApps are that are going to be the first ones that are doing 1 million transactions a day. So what verticals are they in? Who are they? Who are the teams? And we're building a fully open source system. Anyone can come access it. We're going to have a test net, and we're going to be doing a lot of broad, long tail work to make this open to anyone. But we also have resources that our team is going to put forward, and it's called our Scale Innovator Program. So one of our challenges is, where do we put our resources? Which decentralized application projects do we work with? And you almost have to be a bit of a venture capitalist in analyzing where you put your team's resources in more one-to-one work. So that's one of our issues.
And where are you guys? How far along are you along this dream path?
So we will be launching a test net soon, by the end of this year, hopefully sooner.
And what does that test net mean? Can people just join and test out, or do they need permission from you?
Another really good question. I think this industry too is lacking a lot of clear terminology and nomenclature when we think about what's a test net, what's a main net. Our test net really, all of the components of our product are built right now and working independently. There's 4 core pieces that are all coming together. We're doing integration, we're doing bug testing, and then our test net is defined as a fully end-to-end Ethereum connected sidechain where you can show up and you can lock Ethereum on the main chain, run Scale nodes, run consensus, and burn and release back on the main chain in a test environment. That is going to be, that's a fairly broad definition, but that then will progress to, hopefully a 300 or 500 node cluster working in a replicated distributed environment, and then we transition to mainnet where there's servers in the wild processing this, and it has all the other qualities of a mainnet you would expect. So,
cool! I can't wait.
All right.
And Solana, where are you guys at?
What's keeping me up at night?
Do you sleep at all?
Yeah, I do sleep. Like one really interesting and I think often overlooked difference between proof of stake and proof of work is that when my proof of work node gets hacked and does something stupid, I just lose that little bit of electricity, right? Like so, Antminer had a bug recently where they were just censoring transactions. There's no way it was intentional, right? But some misconfiguration and they're just producing empty blocks. And the worst case scenario is that some transactions don't get encoded, or I potentially wasted electricity on a bad block. With proof of stake, my key, my private key that has, like, when it does something malicious can get slashed, that means I lose all my capital, is loaded on a machine that's connected to the internet that's running code that was built over the last year, right? Like, all these proof of stake systems are, like, effectively, rife with 0 days. So if your shard, right, you guys just released a bunch of code, there's a 0 day, somebody figures out and gets all those nodes to do something malicious, right? That's how, like, things can really fall apart really quickly, because we're not based on physical properties like work, right? Like, so that's what keeps me up at night. So we have some ideas, some solutions. As far as testnet, we've been open source from day one. So that was February, and we got multi-node network that can do decent transactions per second up by June. So that's what we call testnet. It's just transactions. It's been up and running with various states of stability. Right now we're stable at 125,000 TPS. And what's cool is you can now plug in and statically link in smart contracts written in Rust that can do all sorts of fun state transitions. And it's going through the exact same pipeline as transactions. So in theory, if your contracts don't do much, they can also do it 125,000 times per second. So that's what we're calling a testnet. It's something people can play with permissionlessly. And it's open to anyone. We have a contest stat of who can take down the testnet. And we'll send you a t-shirt because there's a bunch of bugs there that you can exploit. I'll actually be giving a talk about this tomorrow. So that's my definition, but I really like yours, that you can actually take a known use case in Ethereum, move it over to the sidechain and move it back, and you have functionality of something useful that's being done. And our goal is to get there, as soon as possible. Awesome.
And Kevin, Nervos. Where are we?
Where are we? Okay, I kind of mentioned in general, like schedule, that so right now we have a blockchain that's, like I said, we're open sourcing this month. So we have a lot of stuff working, and then in about 2-3 months we're gonna have a testnet which you can pretty much do the things that run smart contract and payment and stuff like that. And then mainnet will be next spring. But other than that, I think back to your question of like what's more important for Nervos, I think for us it's all about designing the right crypto economics, that's what people call, because first of all we want to say that we want to be secure and we want to be more decentralized. Then it comes back to the question is you have to find the product itself and also the crypto economics have to design for an audience that actually value this, right? Otherwise, there's no demand for our layer 1 protocol, and which is not good. And so if you look at what type of users actually value decentralization or security, if you make a parallel to the payment world where you have Bitcoin and you have other altcoins or like a Doge. So if I just want to make a payment, let's say, I'm on Binance exchange, I want to move some money or value, whatever, to another exchange. I may not use Bitcoin, to be honest. Maybe Litecoin, maybe some other coins, whatever the cheaper, right? Because, hey, it's a few seconds, the money's there, then I'll sell it right away. So my exposure to security is very, very short in terms of time, right? So that's, that's the type of users they're going to go after cheaper platforms and mostly cheaper. And not very secure, but that's okay, because their exposure to security is very, very short. So what we need to do is to find the opposite audience where they value longer exposure, let's say, tokens or assets, they want to have longer exposure to these assets, and they need to store them somewhere. And this is why, if you have the payment space, this is why Bitcoin accrues a lot of value. It's not because it's the fastest, or it's not because it's the cheapest in terms of transaction costs, but a lot of people store Bitcoin because they want to leave there to their next generations, right? They want to say, hey, I'm not going to use this for my life. I'm going to pass it to my son or daughters. So, this is why, we want to be on layer 1 protocol. We want to be, common knowledge base. This is where the name of our layer 1 protocol comes from, right? So we want to be common knowledge base, and then, we want to prioritize not for generating or modifying common knowledge, but for preserving common knowledge. And common knowledge in itself is a logic term or mathematic term, which is basically the knowledge everybody knows, and also everybody knows. Everybody knows. Everybody knows. Everybody knows. So anyway, so that's where you have collaboration. So we want to find the use cases where people value the long-term preservation of these things instead of instant transactions, just like people value preserving their monetary value in Bitcoin and for a long, long time, and then they don't care about transaction costs as much. So that's the use case that we want to target.
And that's very interesting. I definitely want to come back to this topic of use cases. But before we do, let's finish up on sharding now. I think one of the things why people have so many questions is it is a concept that has been talked about quite early on in this whole, if you call the last 12 months of coming out of blockchain to the mass, right? So in terms of sharding, the one question I have in terms of progress is really if we observe some of the earlier projects, including Ethereum, right? Recently, what we've seen is a lot of delays in actually the implementation schedule. How's your team doing? And then how soon can we see actually the dream that you talked about in terms of the whole sharding network working on state and transaction?
Yeah, so I think this is the kind of thing, there's two things which keeps me up at night, and one of them is making this work. Because it's really always very nice to discuss about things and theory. I like theory as much as the next guy, but the hell really happens when you need to transform that kind of theory into practice. And for us, it's trying to solve a lot of hard problems, and this is why even from a prototype to our current phase, we've made a lot of improvements, discovered some obstacles, and with the obstacles, new opportunities to improve and find ways around things. But to come back to your questions, we intend to have the first version of the testnet in about 1.5 months. What will this testnet entail? We differentiate between the first version and the fully featured version. So the first version will have nodes. The first version will still have a controlled setting that will allow you to process everything, sign transactions, propagate within the network, and so forth. It will just not be the first version where everything is open source and public. We intend to make, as soon as we have the fully featured testnet ready, which will take about 3 months. We expect right now we'll also have things open so that everyone can join the network, sign things, test, find bugs, and discover everything. But also to touch on security, I think security is really, really important for everyone in the blockchain space. And there's one key thing about discussing security. You have some boundaries. With enough resources and time and determination, almost anything can be broken down. So if we have quantum computers, there's a lot of discussion right now that almost any blockchain project will not be able to make it, because you will run into different settings with different resources. So what we are trying to do is find ways for each of the component within the settings that we think will work in the next 5 to 10 years to perform optimally and address some kind of needs, especially leveraging scalability in the market.
So I think the next thing I really want to touch upon is a little bit the elephant in the room, right? Because we all talk about scalability as if, oh my God, when it's solved, the world is great. But we all know adoption does not naturally come after you reach scalability. So one of the things I love to hear your perceptions is that from my perspective, I looked at it as the future of many chains. It's almost like different CPUs, GPUs, and ASICs, right? Some chains can be very specific for very specific applications, something. In your case, when you think about your prospective project's use case, based on the technology you're leveraging, where do you see the first wave of users coming from? Whether being very excited about your testnet or eventually be the first to sign on and commit to your full production version? We can start with Jack.
Okay, thanks. So, so we're definitely in this chicken and egg dilemma, right? Well, we don't have scalability, so dApps aren't scaling, but we also, I think, there's a human behavior and just a market adoption trend that's still picking up as well. And I feel like that market adoption trend is going to happen fast. It's going to be slow. We're going to have scalability. Everyone's going to be wondering where the dApps are, where are the transactions, and then it's going to happen. And we're focusing now on use when, again, this is open to anyone, but where we put our effort in terms of really giving one-to-one work with dApps, it's who needs to execute smart contracts fast. And that's our real differentiator. If you're built for Ethereum, really quickly and easily you can get running on Scale. And I think it's where are smart contracts going to be leveraged in current use cases that exist today. There's going to be a lot of use cases and things that we're not aware of today, and we're going to see TCRs take off and a lot of other cool stuff. But where today is there business value by automating smart contracts, and not just, I'm not talking about something where you do a contract once a day, but where can you apply 10,000 bots a day in a smart contract that even can leverage AI and other capabilities? Where are those use cases? And again, those are the use cases we're looking for. We've got a lot of ideas, and we're going to start there, and then I think we're going to see some real innovation happen again in 2 or 3 years where we're not even expecting.
And with that, I'm going to put you on the spotlight, Kevin, because I know your team you mentioned has some experience also building permission chains before you come into this project of permissionless chain. What is your perception? Is it going to be business applications or is it going to be consumer applications? Where are these dApps going to come from?
Yeah, I mean, we use business as a very broad term, but in reality, if you look at the world, I mean, there are huge enterprises, and there are just much smaller, we can say early or late stage startups, which are very different. Our team has a very a big in terms of the business network in China, and we have a lot of smaller companies essentially just finding their ways, be their path to us, and say, hey, we want to use the blockchain. We want to build some interesting application. We have some ideas how to uniquely incentivize our community, by doing tokens and token models and such. But we just can't do it. There's no. We try Ethereum. We try other infrastructure, but there's nothing that we can that we try that works. And what do you guys have? And I think demand is definitely there. And then unfortunately, we have to. All we can say for them now is say, hey, wait half a year. We're gonna be out. We're gonna be great, and we're gonna have a path for you. So we definitely see that a lot of, especially smaller businesses with a huge member base, and then also has some finance characteristics with the core of their business. And then for them, blockchain is going to be, and also in China it tends to be you have a lot of big players that dominate the space. So for the smaller guys to come up and make a inroad to the market, they have to do something very different. So this is why entrepreneurs in China are very excited about, hey, maybe blockchain is our weapon. Maybe it's something we can use. So we get a lot of these inquiries. I definitely see the demand.
So I guess for everyone, what I'm hearing is any industry with a lot of small business players in there that has something to do with finance. So one thing that could fit very well is a supply chain trade financing. But regardless, Solana, where's the use case?
I guess for me, I see there's lots of problems, I think, with adoption of blockchain, because a consumer-facing product, if it hits demand, they can just move to a permission chain or just use Cassandra, right? Like, there needs to be something that users actually care about that's on blockchain. And where I care about it is when I don't have to provide a real identity when I'm interacting with this digital thing. So there's no way my thermometer really needs to know my Google account, right? Like, so in a world where blockchain, I think, is important, is a world where people care about their identity and permissionless interaction with other digital things. So when we can actually self-scale, you can start building applications where your smart devices don't need to know who you are. You just kind of do this self-generated key pair. I don't know where this thing came from. I don't know. It doesn't need to know who I am, and we can just kind of turn things on and off. That I see is important, but it's hard to look at the world now and try to move the current existing things onto chain. People didn't do that with mobile. They didn't do that with the internet, right? We totally missed the boat on like all of those things. And the biggest tech companies in the previous iteration of technologies missed the revolutions. IBM was not the biggest internet company. Microsoft was not the biggest internet company. Google was not the biggest mobile company, right? Like, the smartest people are blind to change.
Exactly. So last comments from Ben.
Yeah, so I think just 2 points here. There's this kind of immediate discussion that every serious blockchain project has right now with respect to adoption. And also this really interesting discussion with respect to long-term view of how things will change and why blockchain might be really, really necessary in that future we're talking about. And I think what we are seeing right now is a kind of really important narrative where once people have lost privacy and have lost ownership of their own data and so forth, and are basically controlled by some of the really interesting tech companies that used to be small and nimble before, they suddenly find themselves fighting for some things that they thought they have. So the freedom, we think, is really good. Once you have tech titans become really, really large, and companies like Facebook having so much influence with respect to who's going to be elected and what happens and so forth, then you suddenly start to understand that it might be necessary to have a way of using your digital, sorting your digital life without the need for someone to control it, to be able to censor it, and so forth. So there's two discussions for us. On the one hand, it's clear that there are startups that want to leverage scalability and find ways to build identity and other core things for the digital economy. And long term, there's all this discussion regarding how you build a new layer within the internet, which allows for censorship-resistant, unstoppable application and privacy and identity.
Great. So to wrap up, I'm going to ask all of you just one question, and I want either one word or very simple answers. 12 months from now, if we come back and talk, I hope we're not talking about scalability again. What topics should we be focusing on in 12 months if everything go as planned? Quick.
I think real usage.
Usage. Ben.
Definitely adoption.
Adoption.
I think smart contracts.
Smart contracts. And
I think we'll be talking about security.
security.
Yeah,
Cool.
definitely. The kinds
Great.
of hacks that will be possible with multi-billion-dollar blockchains running.
And with that said, I know we're out of time. Thank you very much. And I know anyone who wants to hack Solana, he's actually teaching you how to hack it. I think there's a session, so go find him. Thanks, everyone. Thank you, guys. I learned a lot.